All right, how is everybody doing today? Welcome to General Chemistry Gems, GChem Gems as it were, for DAT, OAT prep. Question about the recordings is I'm working on getting HPA has a YouTube page. We're trying to make sure we can get logged back into it so I can post them via YouTube. So hang tight, we will get there. We're working on that diligently right now. So today we're going to be talking about general chemistry, some of the different question types and content that you're going to see here. And it's different than what we saw with biology. Biology is more just straight, like pick the answer type. There was some strategy we could see there, but now we're going to see some more mathy questions, and there's more types of questions that we can generally see in GChem. So just a reminder of how this fits into the DAT and the OAT as a whole is it's part of that marathon session of 90 minutes through the biology, GChem, and OChem. This is the middle section of it, which gives your 30 questions. Now, remember, I said you should probably go faster on the bio, spend about 3/4 of a minute on those bio questions because you have 40 of them. Now that we're dealing with 30 and 30 of the OChem and the GChem, should be probably slowing your pace down a little bit to a minute per question. Mostly, we could, like, not just because the bio is first and you want to make sure you get through to the GChem and the OChem, but also some of these questions involve more investment of time. There might be a question that you have to do a calculation, or there might be a question where you have to set up a calculation. So it's worth slowing down here. And it's maybe not even to the 1 minute pace. You might still save some of that time for OChem by going, pretty quick through some of the questions. And remember, why do we need to do this? Why do we need to balance this section? We get a score for how many of these subjects? Do we get a score for the whole section, or do we get a subject per subject?
I think it's per subject.
It's per subject, and that's the problem. So if you do well on bio and GChem, but just tank organic completely, it's going to tank your average. So you got to give equal time to each of these parts of this section. It would be different if you just got one survey of natural sciences score, but you get a bio, a GChem, and an OChem score. So you got to make sure you're giving enough time to each question or to each group of questions. So what is the content of general chemistry look like? In general, it's what you would probably come to expect. You're going to see percent composition, empirical formula, balancing equations. Those are all fairly common questions, but they don't tend to have you actually do calculations some of the time. They're going to have you do more like estimations or set up the calculation with those kinds of questions. They'll like give you 4 different or 5 different equations and have you pick the one that has the correct numbers in the numerator and the denominator and multiplied or added or whatever together. Then you get into gas laws, and for the most part, you don't really need to distinguish between Dalton, Boyle's, Charles, Avogadro's, all those laws. Really, what's the one? And I know everybody knows this, even if you haven't even taken GChem yet, you know the answer to this question. What's the one most important gas law that you're going to run into on this test? You can just type the equation. I know you know it. I'll give you a first letter. There we go. All right, I didn't even have to give you a first letter. Just had to wait long enough. PV equals nRT. So you already know the equation you need for this section. Like, this is really it for equations per se. You got to understand liquids and solids, so phase changes and things. So intermolecular forces becomes key here. Remember IMF, intermolecular forces, things like hydrogen bonding, dispersion forces, dipole forces, because the more IMF I have, the more likely or the less likely I am a solid. The more IMF I have, the more or less likely I'm a solid.
The more
likely I'm a solid. Because if I have more intermolecular forces, my particles are held together more tightly, which means I'm more likely a solid. So a lot of the stuff about liquids and solids is really dealing with the idea of having intermolecular forces. In fact, if you remember, for gases, one of the assumptions we make is that they have no intermolecular forces at all. Solutions, colligative properties. This is something that some people may have forgotten about. These are things like boiling point blank, vapor pressure blank. So what are some of these blanks? Boiling point, elevation, or depression? Does the boiling point go up when I have a solution? Does it go down when I have a solution? Boiling point blank. Goes up. So we would say boiling point elevation, or I would say freezing point blank, freezing point elevation or depression. And I always remember this one because it's depression. I always remember this because a solution will have a larger liquid range than a pure liquid. So the boiling point will go up, the melting point or freezing point will go down. And so you always extend that liquid range. So make sure you remember those colligative properties. If there's anything that you've probably forgotten, that's probably it. pH, how you calculate pH, your basic pH equations. There's one other equation you probably should know coming into the test, and that is the Henderson-Hasselbalch equation, because that is the pH of a buffer. So they do like buffer questions from time to time. Thermo, know your thermo concepts, just delta G equals delta H minus T delta S. Be careful with some of these terms, because if I say a reaction is exothermic, if a reaction is exothermic, its delta G is negative, correct or incorrect? If it's exothermic, delta G is negative. Is that correct or incorrect?
It's exothermic, correct.
That is incorrect. I got two of you. What is incorrect about that statement?
Oh, bloody.
It's an easy trap to fall into. This is why I'm asking it. When I say exothermic, what am I referring to? There you go. It's supposed to be a negative delta H, a negative delta H, not a negative delta G. If I were to say exergonic, delta G would be negative. So it's like, it's little things. It's like the way we spell a word. So you just gotta be careful. Exergonic versus exothermic look a lot alike, but they mean different things. So re-up yourself with that kind of information. In fact, I'll ask another common thermodynamic trap. Breaking bonds is always exo or endothermic. Breaking bonds is always endo or exothermic.
Endo.
Uh-oh, I need a tiebreaker because I got an endo and I got an exo. Oh, the tie went the wrong way. Breaking bonds is always endothermic, because you have to put in energy to pull the atoms apart. You're gonna pull those atoms apart, break it apart from each other. And there's a pretty good reason why many of you might have thought it was exo and firmly believed it was exo. You have probably been in classes where they told you that the dephosphorylation of ATP, breaking phosphate from ATP, is exothermic, which is actually incorrect. It's exergonic. It is not exothermic. So let me write that down actually, because that one's such a big deal that I see people making all the time. ATP dephosphorylation, we turn ATP into ADP. Boy, I can't write with this cursor. ADP plus phosphate. Delta G for this reaction is positive or negative?
Negative.
Delta G for this reaction is negative. It's exergonic. But delta H for this reaction is positive or negative?
Negative.
Delta H for this reaction is positive because it's a breaking of a bond. You're breaking the bond to pull the phosphate away from the ATP. So it's made up for by the change in entropy, which makes this an exergonic reaction. So like this one reaction right here encapsulates a lot of the confusion that comes about in the thermodynamics types questions. And then kinetics. Kinetics is just your basic rate law stuff. Oxidation reduction, just be able to assign oxidation numbers. You're not going to be doing a lot of calculations. You might calculate a cell potential from half reaction potentials. Know what like orbitals are, where electrons sit in orbitals for certain atoms, electron configurations, periodic properties, pretty self-explanatory, you know your basic ones. Nuclear reactions, people tend not to get to in their undergraduate chemistry class. It's one of those topics a lot of professors skip, but really just know alpha, beta, gamma decay. Know your alpha, your beta, and your gamma decay reactions, and you're good to go. And then finally, laboratory questions. These are the weird ones. You'll get 1 or 2 lab questions, which will ask things like, what kind of glass, what would be the best type of glassware to use to measure volume? Beaker, Erlenmeyer flask, graduated cylinder, volumetric flask. And like, okay, volumetric flask, because I can measure numbers most accurately with that. Things like weird lab questions. You might have to do a little bit of studying up on that stuff. So there's a lot of content that could be covered in the GChem. They just can't cover it all very well. So there's going to be things that don't show up from time to time. So let's look at a few questions and some of the ways that we can go through it. Now, this question looks like it's a heavy math question. Do you get a calculator on this section of the test? No. So since you don't get a calculator on this section of the test, will the math be easy to do or hard to do by hand? It's going to be easy to do. So you just got to look for the easy to do part of it. So if I'm looking at this 49 gram sample of H2SO4 and I've got 98 grams per mole, what makes that math easy? How many moles of H2SO4 do I have? Well, look for it and you'll see it. How many times does 49 go into 98? It's going to be an integer. It's more than 1. It's 2. I should be able to just be able to look for integer type answers for questions like this. So don't overdo the math. Don't try to do long division of like 98 divided by 42 or something like that. So 49 goes into 98 2 times. So how many moles of sulfuric acid will I have? Will I have 2 moles or will I have 1/2 of a mole? And here's where units can help you. I'm going to have 1/2 of a mole, because if I look at my units, if I have 49 grams and I need to get to moles, and I like using what I call the railroad track method. I'm going to put my 98 grams down here and my 1 mole up here. Grams cancels and gives me moles up top. So using the railroad track method, I can really simplify the math I need to do. So it's going to be 49 over 98, not 98 over 49. So I've got to have 1/2 a mole of H2SO4. So then I should be able to look at most of these straight up. So do I want to look at answers B or C first? Why not? Why are B and C bad choices to look at first? Yeah, let's just look at the mole answers first, since I've got moles already. So I got 1/2 a mole of H2SO4, so will I have 1 mole of sulfur? Is A good or bad?
Bad.
It's bad, because I have 1 sulfur for each mole of the compound. So if I got 1/2 a mole of the compound, I'm going to have 1/2 a mole of sulfur. So then I'm going to look at 2 moles of O. Well, if I have 4 moles of O and 1 mole, then I'm going to have 2 moles. So there we go. That's my answer. D is correct. So yeah, D is the correct answer. And you notice what I didn't do here. Did I do elimination tactic like for all the answers on this question? Absolutely not. And there's a reason for it. This is a calculation question. There is one right answer. Now I don't have to worry about that, like maybe subtle or whatever. I'm not going to have to eliminate all the others. Once I find the correct answer on a numerical question, go ahead and pick it. Don't get into like, I have to eliminate all the other answers on a question like this. It's not necessary, because once you find the right answer, it's the right answer, and go on. Just be smart about how you approach it. I don't need to deal with grams if I can just find my answer in the moles. Everybody with me? So stoichiometry. Now I've got another stoichiometry question, but notice what they did in this one. Do I actually have to do a calculation here? I just have to set it up. So they're asking me for what is the percent of nitrogen in a compound. What I would suggest doing is just write down what that means. So percent nitrogen is going to be what? It's going to be grams of nitrogen divided by what? What are all percents, by the way? Part out of the whole. Yeah, so grams of the compound. Grams of compound times 100, but all my answers have that in there. So how am I going to find the mass of the compound? I've got 3 grams of a nitrogen oxygen compound. It's found to contain 2.22 grams of oxygen. So they already gave me the whole. The 3 should be where in my calculation? It should be in the denominator. So let's eliminate. Where are some bad answers here? And now we are on to process elimination. These are great POE questions. Which answers do not have that on the bottom? A, E, and looks like that's it right now. Okay. And then I need to find the grams of nitrogen. So if I want to see grams of nitrogen, that's 2.22 grams of oxygen. How am I going to be able to find the number of grams of nitrogen? Subtraction. I've got addition, nope. I've got using oxygen, definitely nope. So my answer is D. So these kinds of questions, since they're not numerical questions, become straight up elimination tactics. So it's not the number of grams of oxygen, that's C. It's not the sum of them. That would be, I don't know what that would be, and it's got to be the difference. So look for the differences between answers. They can help direct you to the correct answer with this type of question. And for the person who asked about recordings, again, the recordings are going to end up on YouTube. They are not yet available. I'm working on that right now. All right, another question we might see. Water has a higher boiling point than compounds of similar weight. What's the best following explain? God, that was just a word soup. Let me try that again. They're asking about water being different and unique. What is always the answer to why water is unique? And I'm going to say this is just what it is. It's always going to be hydrogen bonding. Everybody should get this question right. Every time you see a question saying, why is water weird? You should always go, hydrogen bonding. So what's the answer?
A.
It's going to be A. Boom. And this is so much of a predictable question. I'm pretty much going to say you're going to have a question similar to this. It won't be exactly the same, but you're going to have a question similar to this on every single test, because water being unique is a pretty characteristic question, and it's unique because it's got hydrogen bonding. So always be on the lookout for that. Sometimes questions are that straightforward. All right, you got to know properties of compounds. Let's see, a substance is non-conducting as a solid and melts at 750 C. The melt conducts electricity. The solid is observed to be soluble in water. The substance would be best classified as blank. So we got to use this information one piece at a time. Our molecular compounds, like I'm going to deal with the first thing, the solid. It's a solid with a high melting point. Our molecular compounds usually solids. O2, H2O, N2. Nah, they're not. Our ionic compounds usually solids. Sodium chloride, potassium chloride, magnesium chloride, sodium nitrate. Are ionic solids usually solids? Given my screw up in speaking, what is yes, ionic solids are usually solids. Yes, so don't eliminate that. Are macromolecules usually solid? Yeah, big molecule proteins and fats and sugars. Yeah, they're usually solids. Are metallic compounds usually solids? Lead, copper, iron. Yep. And polymers, are polymers usually solids? Yeah, I mean, I'm drinking out of a plastic cup right now. It's holding my water. So the only one we could eliminate there is the solid part. But I also got non-conducting. So which one of these are which one is conducting out of those last remaining four? Which one conducts electricity? So it can't be D because it has to be non-conducting. So look at what I'm doing. I'm parsing it out one little piece at a time. Solid, non-conducting, okay. Then the melt conducts electricity. Which one of these is going to conduct electricity when it's melted? The ionic compound. So it ends up being ionic. I don't have to necessarily get through all the features. And moleculars are usually not solids because things like O2, N2, H2O, molecular compounds tend to be liquids or gases, not solids. So with these kind of wordy questions talking about properties, the thing I would suggest to do here is like deal with it a little bit at a time. Don't try to answer the whole question at once. Try to encapsulate all the information. Just cross out, do process elimination with little pieces of information at once. And you can use the strikeout tool to like cross out little things as you go, like kind of what I did there. Then you get these wonderful questions. Which of the following reactions is water considered to be acting as an acid? So this is a very common setup. Where is water in the first equation?
First one.
It's on the reactant side or the product side? It's on the product side. So can it be acting as anything if it's a product? No. So this is the first thing I do on every one of these questions where it says, blah, 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 is this compound acting as? Or is it a blank reagent, like oxidizing agent or reducing agent? The thing that's doing something, if it's acting or being an agent, it cannot be on the product side. So besides A, which other answer can we cross off? E is out. You can almost always cross out 2, sometimes 3 answers doing that. So now what do I have to figure out? Well, I have to see water doing what process? What does an acid do?
Donates a proton.
It donates a proton. So in which one of these is it donating a proton? Yeah, in B, it's gaining a proton. In C, it's gaining a proton, which means D must be my correct answer because it's losing a proton there. So now you just use your basic definition. But if you can eliminate some of the weird answers, the bad answers right out of hand, you're in a much better place. Here's another setup, but of a topic that many people are not comfortable with, and this is solubility product. How many people would say they're comfortable with solubility product questions? For the most part, that's like one person out of 12. So good. I'm happy for you. That's a good thing. That's actually really great. A lot of people though come out of school or GChem without not really feeling comfortable on KSP questions. The thing to do on KSP questions is this: write the equation. Write the equation for the dissolution, because it'll help you just deal with the problem at hand. What is the equation, the important equation here for this equilibrium? Everybody take a second, write out the equilibrium equation you would have for this process, for this problem. I'll get you started. AgCl solid dissociates into silver plus and Cl minus. That is correct. And notice you have one of each. This does not end in the equilibrium. This is S and this is S. And then you just write your KSP is the equilibrium constant of this equation. KSP is going to equal products over reactants. So what is my equation for this KSP, for this equilibrium? Just S squared. So there's your answer. Now, once you've done that, you know your answer. A is tempting, B is not, C is not, D is not, and A isn't squared because it's got the 2. So watch out for that little goof, right? That's a, what do we call that kind of an answer? They put as A and it looks really good, except one teeny tiny little thing is wrong. That's our distractor. That's our trap answer. It's a mean problem. That too. So what the thing to watch for is just like make sure you're paying attention to those things, because it's really easy to pick A because it looks right. It looks good. It looks like something times something, but it's only different by that one number. So make sure to look at the answers very carefully. All right. Here's another one. Which one of the following is the best reducing agent? This is kind of the flip kind of question that we saw before, but this time they're asking me which one is reagent. So which answers can't be reagents? Stuff in the products, right? So which things are in the products? Which answers can I just immediately get rid of? D and C are both products. Neither one of those can be right. Neither one. Now, I'm going to teach you again another mnemonic. So I mentioned mnemonics last time as good ways to remember information. Here's a great mnemonic that I don't think anybody probably ever got in their G-Chem class. Reducing agents are mexes, MEHX, and metals. Oxidizing agents are MOXs and nonmetals. So what is the MEHX? That's something like sodium borohydride, NaBH4, or lithium aluminum hydride, LiAlH4. A metal would be just a pure metal. An MOX would be something like MnO4 minus, or CrO4 2 minus. A nonmetal would be something like pure nonmetal, like I2 or F2 or O2. So just looking at our answer choices here, we're looking for a reducing agent, right? Well, what is A? A is an oxidizing agent because what category does it fit into? It's a MOX, it's an MOX. Is H plus or is hydrogen ever going to be oxidizing or reducing agent like that when it's H plus? And this is just a fact you should know. What is H plus? It's not, it's an acid. H plus is an acid. So what's the answer? I minus. So you don't always necessarily need to look for the MEX to find the reducing agent or the M, but we can get rid of the MOXes pretty easily that way. So it's a nice way to keep these things sort of categorized, because I know it's hard to remember all those oxidizing agents. You've got an organic chemistry, because that's when you got most of those. MEXes and MOXes was organic chemistry. So mnemonics, they can be your best friend. Let me give you one more mnemonic while we're at it for mnemonics. It's not related to this, but have no fear of ice cold beer. Have no fear of ice cold beer. What is this a mnemonic device for? All of these elements are what kind of elements?
Electronegative.
They are that, but they're also special in the sense they are. Do they come individually or do they come like Twinkies?
Individual. Well, the gases. No,
Nah, these come as Twinkies. These are all the diatomics. H2N2F2O2 I2 Cl2Br2. These are all the diatomics. And the reason I like this particular mnemonic device is because of this reason. What state of matter is fluorine? Solid, liquid, or gas? It's a gas. What state of matter is bromine?
liquid.
Not a solid.
It's liquid.
It's liquid. But if I forget that it's liquid, there's an easy way to remember it. What state of matter is beer? Beer is a liquid. What state of matter is iodine or ice? Solid. The rest of them are gases. And iodine and bromine are two elements that people always forget are liquid and solid, are solid and liquid respectively. So good mnemonic devices have multiple purposes. So look for these mnemonic devices. They're going to help you remember information in kind of a fun way. I like this one. It's fun to say. Have no fear of ice cold beer. So hopefully I just taught you a little something there. All right. In which two compounds does nitrogen have the same oxidation number? They like these oxidation number questions. You just simply have to know the rules. Do you guys remember the rules of assigning oxidation numbers? Rule number 1, elements are 0. Are there any pure elements in here? Pure elements? Do I see like N2 or O2 by itself? No. So no elements. Rule number 2, monoatomic ions are equal to their charge. So do I have any monoatomic ions in here? Not really. Those are things like metals and chlorides and fluorides and sodiums. And so I don't have that. Oxygen is usually -2. So I do know those. Like that's -2, that's -2, that's -2, that's -2, and so on and so forth. And then hydrogens are generally what charge or what oxidation number? +1, +1, +1. And then halogens are almost always what charge or what oxidation number, I should say? -1. And then really that's most of what you need to know, because then everything else should just add up to the overall charge. So if I am looking at A, N2O3, I've got N2O3, I've got -2 here. So what does the nitrogen have to be? You're right, because I've got 3 oxygens, which gives me -6, which means I need +6 of a contribution from the nitrogen, which means each nitrogen must be +3. So don't forget that you have to have the total, like you have to consider the total overall charge based on oxidation numbers. These are the individual oxidation numbers. So HNO3, what's going to be the nitrogen in that guy?
Negative.
Agree or disagree with +5? Yep, looks like we got some agreement. It's +5. So it's not A, and we already know +5 for this one. So what is it in N2O5?
+5.
Yep, in in N2O5, it's going to be +5 as well. So that's what we're looking for. That's our answer. Boom. So review your oxidation number state rules. You have to have those memorized, like in order. You got to use them in order. All right, here's another one that is a nice mnemonic. I'll show you in just a second, but let's see if you guys remember this one. Which of the following properties increases with atomic number among the representative elements of period 2? Blah, blah, blah. That's a lot of words. But what is it really saying? Let's pick that apart. It's a periodic trend question. Here's our periodic table, and they're saying increases with atomic number among the representative elements of period 2. So say here's period 2. We're asking what's increasing this way? So does atomic radius increase from left to right? Nope. Does electronegativity increase from left to right? Yep. Wham. There's our answer. So here's my mnemonic device for this. B-E-A-R. Bear. B-E-A-R, clockwise around the periodic table. All your electric properties like electronegativity, electron affinity, ionization energy increase up and to the right. Acidity increases down and to the right. Basicity increases up and to the left. And radius increases down and to the left. So BEAR, basicity, electronic properties, acidity, radius. Love me some mnemonics. All right, one more. Let's see if you guys know this one. The reaction shown below has a nitrogen nucleus containing 6 neutrons and emits a positron. What is the second product of the balanced reaction? So this is what I was talking about. This is one of those topics that some of you may not have run into, but it's really just counting particles. So you have to know your alpha particle is a helium nucleus. So an alpha is going to have a mass of 2 and an atomic number of 2, or sorry, a mass of 4 and an atomic number of 2. A beta particle is an electron. It's going to be -1, 0 like this. A positron is a positively charged electron, which is going to be 0, -1. A gamma ray is going to be 0, 0 for its particle count. They were nice to you in this one is they gave you the positron. They gave it to you in the equation. And what has to be true about the numbers in the top? They have to balance. And what has to be true about the numbers in the bottom? They have to balance. So what's my missing number up top? $13, that's right. So I've got to have a 13 there because 13 plus 0 is 13. And what's missing in the bottom? 7 has to equal 1 plus 6. And most of the time, this uniquely identifies the answer. You probably will not need to look at the periodic table, which you will have available to you on the test. They will give you a periodic table. But do you really need it? Nope, because what's the only answer that shows a particle count of 13 and 6? D. D for done. D for that's how these work. So know what an alpha particle is, know a beta, know a positron, know an alpha, know a gamma. And if you get a half-life question, don't be clever with half-life questions. So if the question says, how much is left after 4 half-lives? So I'm starting with 2 grams. How much is left after 4 half-lives? I know people that try to plug this into an equation. Don't do that. There's no reason to use equations here. Don't be clever. Just brute force this thing. How much is after 1 half-life? How much after 2 half-lives? How much after 3 half-lives? How much after 4 half-lives? 1/8. So these questions are going to be so easy if you just do it this way, that like if you try to plug it into equation, what usually happens is you forget that there's 4 gaps and you do only 3 gaps. Like you count it like 1, 2, 3, 4 instead of 1, 2, 3, 4. So that's the mistake people usually get. It's off by 1 mistake. So you forget to account for 1 more of those transitions. But hey, when you're stressed out, keep your processes simple and just dumbify it and just do the question. Boom, 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 and you get your answer. And there you go. So this is kind of an overview of some of the things you're going to see in chemistry. Like, was this the same as what we saw in biology? Did it feel the same? Yeah, it's like the switch between the bio and the G-Chem is pretty stark, because you go from like more, it's just fact recall, to now I have to do more figuring, right? Yeah, exactly. Bio has a lot more of like, you know what's connected to what, you know the different terms. Here it's more like there's things you can figure out. You could actually not know something and probably eliminate your way down to it more easily in G-Chem than you can in bio. But also G-Chem is a little more intimidating because it's honestly, it feels like it's a broader subject, because there's all these little things they can ask you about, but they're not going to ask you about every single thing. So I do think G-Chem is harder to study for than bio, because you have to be aware of the different types of questions. So here's how you get better at G-Chem: do a lot of practice questions, so you're not surprised by anything. More practice questions is always going to be better. Yes, and the questions are often more time intensive because you've got things you have to do, steps that you have to do. So that's why you want to go faster through that bio, so that you have the time to do the G-Chem questions, and then eventually the O-Chem questions, some of which are even more time intensive because of the fact that they're synthesis questions. So yeah, it's all about timing in this section.